We're going to look at some characteristics of the graphs of functions for section 3.2. So our first question is to find the intervals where the function is increasing, decreasing, or constant. So, and it kind of goes like what you would feel. So increasing is climbing, and you go from left to right. So it's climbing in this section to right here. And then it's going to go start down to right here, and then it starts climbing again. When you give these intervals, you always work with x, and you will always use parentheses. So the first one that is increasing is, this is going to go on to negative infinity. So we're going to come from negative infinity to negative 2.5, it looks like to me. And actually, I have to go back to that because you have to give all the sections where it's increasing. So it was increasing here. It's also increasing here. So I'm going to want to go back here and do a union from 1 to infinity. Now we'll get the decreasing interval. This is the only section that's decreasing, and it is from negative 2.5 to 1. There is not an interval that is constant. There's not one place where it stays the same, like a horizontal line. So this is going to be does not exist. And there we go. Question 1. All right, let's try one more. And I went to question 5. Same kind of questions. So this one is increasing, and you have to assume this goes on forever when it goes all the way to the edge. So we have one piece that's increasing and one piece that's constant. So it's increasing from negative infinity to 2. It is not decreasing, and it is constant from 2 to infinity. Our next thing we're going to look at is a relative max and a relative min. And so a relative maximum is the highest point in a neighborhood. So right here would be a relative maximum. This would be a relative minimum. So the lowest point in a neighborhood. You never use the ends. And so there are two questions. The x value of the point tells you where it is. The y value tells you the value of it. So you have to watch those questions. All right, let's see if I can get the questions and keep the graph. All right, so a relative maximum, and we could blow this up a little. So a relative maximum is going to be at 2, that's my x value, and the value of it is 5. So it's going to be at, the x value is 2, the value of it is 5. Right? And now we'll go back and look for a relative minimum. It's going to be this lowest point, and so the x value is 4. So that's where it is, and it is 1. So that is max and min. Let's see, I picked question 10. This is a nice question, easy to see. Right, here is your max. And so that is going to be at 0, and the value will be 4. You can go ahead and put that in. It's at 0, the value is 4. And for the minimum, you have 2. All right, you have one at -3, and you have one at +3, and the y on both is -2. So at -3 and +3, and I said this is -2. Right, and then I wanted to backtrack to problem 9. This one, don't be tricked by it. It doesn't actually have a relative maximum because this is continuing down. It's not like a hump, right? It's continuing to go down. So this one does not have a relative max or a relative min. So does not exist. Next, we're going to look at symmetry. And the symmetry, it has symmetry with respect to the y-axis. And to find that, we'll plug -x into x. That means it's going to flip across the y-axis. Symmetry with respect to the x-axis. And to do it, we'll plug -y into y. And symmetry with respect to the origin. Your origin is 0, 0. So it rotates around 180 degrees. To find it algebraically, to see if it has it, we plug -x into x and -y into y. So this question, x equals y squared plus 4, we want to know if it is symmetric and to which of those, if any. So it will be an algebra problem. We'll just run through the list. So actually on my list, I put symmetry to y first. So let's plug -x into x. And does it give us back the original? No, it does not, so it is not symmetric to y. right? Then we will try it for symmetry with respect to, WRT is with respect to the x-axis, and it says plug negative y into y. So our original is here, so keep your x, and for your y, we'll plug negative y in. When we clean that up, squaring that negative makes it positive, and that one does give us back the original. So it is symmetric to x, and then we'll try symmetry with respect to the origin. So we have to plug negative into each of them. So negative into the x and negative into the y. This one is still going to give us negative x, and this will give us y squared plus 4. So this does not give us back the original, so it's not to the origin. So you can kind of tell from here when you're squaring things. So something to an even power, it's going to change those negatives to positive and give you back the same. So our answer here is with respect to x. And some of these you'll have more than one choice. Right, and I picked one more, number 13. And we'll get a similar question. Sorry, just take a second here. I wanted to keep my definitions up. And it was x squared plus y squared equals 15. So if we test it for symmetry with respect to y, that says plug negative x into x. So I'm just going to write WRT with respect to y. So negative x into x. And we're squaring, so yes, this is. It gives us back the original. So we have that one. If we try with respect to x, you plug into the y. And yes, it gives us back the original, so it's symmetric to x. And then symmetric to the origin. And you might have a feeling for this one because you're plugging it into both of them, but they're both squared and there's nothing else there. So it's going to give you back the original. So this one is symmetric to all. This picture, we haven't learned this yet, but it is a circle. So we have symmetry to all three of these. Next, we're going to look at symmetry, but we're going to talk about odd and even. And these are going to be functions to have this. So if a function is even, it's going to be symmetric to the y-axis. If it is odd, it will be symmetric to the origin, which is here. It doesn't have to be either one. So this first picture they're giving us is neither one. It doesn't have something over here to match it. So this is going to be neither. Our next picture, and let me just get more space since I don't really need to write for this one. This one, notice how if you flip it across the y-axis, it gives you the same picture. So this one is an even one. It is symmetric to y. This one is an example of symmetry to the origin. If you rotate this around 180 degrees, it will give you the same picture. It would move this one up here and this one down here. So this one is an example of to the origin, which is odd. So even is to the y-axis, odd is to the origin, and there's not one that's symmetric to the x-axis because that actually does not give you a function. Right, I also picked the next question, 15. This one you can see just looking at it, it's symmetric to y. It is not symmetric about the origin, so it's just a visual thing. So if it's symmetric to y, that is even, and that's going to be our answer. Click the answer key. Okay, let's go back and see what, oh, I didn't answer the last piece. This indicates that the function is symmetric with respect to the y-axis. So you'll have to watch for that on that problem. Right, and then I picked question 17. So this is looking at the equation of the function, and there's a shortcut if you look at the exponents. If the exponents are all the same, so if the exponents are all odd, it will be odd. If the exponents are all even, like this one, then it will be even. If you have a mixture, then it will be neither. If you have a constant, you have to remember that's a number times x to the 0, which is even. So our first one is x to the third and x to the first. So this one is going to be odd because those are both odd. This one is an example of even. This one, if you write it out, it's x minus 4 times x minus 4. So you have x squared minus 4x is minus 8x plus 16. All right, so you have 2, you have 1, and you have x to the 0, which is also even, but you have a mixture. So this one is going to be neither. Right, our next type of question I picked, number 19, has a lot of questions about this graph. Let me just clear this. Side. So here's our function. And the first question asks us about domain. So remember, domain has to do with your x, and so we're coming from negative infinity, and this one will continue across as it goes up. So this one is going to be negative infinity to positive infinity for my domain. My range is lowest to highest. So lowest point here, you're going with your y, is negative 9. And it can be either part of your picture. This goes up forever. So that was negative 9. And it's going to touch at negative 9. So that will be a bracket. and it goes to infinity. So I need the bracket first and then the parentheses. So -9, comma, infinity. Right, that's range. X-intercept, so the point where the graph crosses the x-axis at -6, and this looks like 0. Right, a y-intercept, and it is here, it is 0, 0. If there's any one you can't see, remember you can blow this up. All right, y-intercept is 0, 0. All right, the open interval on which f is increasing. Right, so where is it climbing? Well, this is constant, this is going down, this is going up. So from here, and remember, increasing, decreasing, those use the x values, and you will always use parentheses with those. So from -3 to infinity, it will be increasing. Your order does matter on these, so it needs to go in the same order you have from left to right. Decreasing, so where is the picture going down? From here, which is a -7, to right here, which is a -3. So -7 to -3 is decreasing. Where is it constant? This picture did have a part that's constant right here. So this is coming from -infinity up to -7. It is constant. Right. It wants to know if there is a relative minimum, so a lowest point. Yes, here is a relative minimum, right? It occurs at -3. The value is -9. So it occurs at -3. And they give you the x, so that's helpful. And the value of it is -9. Right, a relative maximum. This picture does not have a maximum. You don't use endpoints or the ends of the graph, and this it's not a highest point in the neighborhood. So these two do not exist. Right, we want to find f of -9. Right, so when x is -9, so f of -9. So when x is -9, where is y? So x is -9 is right here. So the y that's in the constant region is 7. Then it says find the x value for which f of x equals -9. If you get stuck on this, remember f of x is y. So we'll go back to our picture. And so we want to look when y is -9. So that is here. What is the x value? So the x value would be -3. And then they ask us about, is it even, odd, or neither? So this is just a visual thing, right? It does not flip across your y-axis, so it's not even. That one's out. It does not rotate 180 degrees and give you back the same. So this one is neither. Next, we're going to look at piecewise functions. And these functions, different parts of them are defined by more than one rule. So this is what a piecewise function will look like when it's written algebraically. And you have to use the rule determined by this part. So first, they just want us to find f of -4. So we have to use the right rule and plug in. So -4 is less than 0. So we want to plug it into the top one. So -4 goes into the x, 6 times -4 plus 1. So -24 plus 1 is -23. Next, they want to find f of 0. So you have to look closely. Right? The top one is less than 0. The second one is greater than or equal to 0. So for 0 itself, you have to use the second one. So -9 times 0 is 0, minus 5 gives us -5. So this kind is not hard. It is just watching, being careful to pick the right rule. So f of 4, right? 4 is greater than 0, so you're going to have to use the second rule to plug in. So -9 times 4 minus 5, -36 minus 5 is -41. Good. That one just has 3 separate things, so I'll leave it for you to do. And this one I want to show you because it's a little harder to do in the software. Let me just clean this up real quick. And so what we're going to do is we're going to graph both of these on this same grid. And so let's look at each one. And we'll do these with a chart. This is a line. So we have y equals -3x plus 3. And this is when x is less than 0. So we'll do a t-chart. And you always want to pick the one that is with your condition. So we want to pick 0, but we'll put a star by it. It's less than, so we'll go up to the 0, but we're not going to touch the 0. Right? And then we have to pick something else, and we have to pick things less than 0. So let's pick a -1. Right? So we're going to pick these, and we're going to plug them in. This is a line, and if we were not graphing it with a condition on it, we could use slope intercept easily from this. All right? But with the condition, we'll use the table. So if we plug in 0, y equals -3 times 0 plus 3. This is 0 plus 3 is 3. And then we'll plug -1. So y equals -3 times -1 plus 3. Two negatives multiply to give you positive. 3 plus 3 equals 6. So this will be one of our pieces on our graph. So let's go to the graph, and your tools are down here. All right, we have less than 0, so we're going to use an open circle first to get the end point there, and we're going to plot it 0, 3. So don't go over, go up 3 and click. All right, next, remember, this is going to be a line. It's actually just part of a line because it doesn't go forever the other way. So we're going to use the ray tool. So we'll click that. We have to go back to the first point we already plotted. Click it again because you're going to start there. And then we will graph one more point. So -1, 6. So -1, 6. See, it's trying to put the ray on there. Click again, and that will set that piece. Now we'll graph the other piece. So let's see if I can just scroll down. It's not that far. So we'll do a table again. X, Y. This is also a line. You can tell that by the exponents. So y equals 4x plus 1 when x is greater than or equal to 0. So again, we're going to pick 0. We'll put a star by it. This time we're going to include it. And so we'll do 0. Y equals 4 times 0 plus 1. So 0 plus 1 is 1. And then let's pick something bigger than 0. So if we pick a 1. So we'll have y equals 4 times 1 plus 1 is 4 plus 1 is 5. So we go back to our grid. We're going to do for 0, 1. And this time, because it has the equals underneath, we're going to do a solid dot. So over 0, up 1. Click there. Then you're going to go back and click your ray tool. Go back and click that point you just plotted again because that's the end point of your ray. And then we're going to do 1, 5. So we're going to go 1, 5 right here. And that is our graph. Sorry. All right. The questions below, it has two questions for us. First, it asks us the range. It wants us to look at all of it together as one picture. So the lowest point is 1. And this one, you have to look back and think, this one was a solid circle, right, from this. And so we're going to do a bracket, and it is from 1. And you can look at either end. They go to infinity. So we're going to do bracket first to parentheses. And, sorry, I forgot what it said. 1, comma, infinity. Then it asks us f of -3. So we look and see where is -3. And -3 goes with this picture, right? And it's way on up there. I don't have a tool to blow it up, so what we should do is do it algebraically so we can get an answer. So make sure you're using the right rule. So -3 is less than 0, so we need to use this rule. So we use the top rule. So we're finding f of -3. And we're going to use this rule because it's less than 0. -3 times -3 plus 3. This gives us 9 plus 3 is 12. So it's just on up a bit. Good. Let's try one more. And this one has something special on it. This is going to be a horizontal line. It's going to be y equals 7. And it just has the one value. Up above, you have a note about what to do for that. So your notation will be this piece. All right, so let me get a clean area over here. And we'll do them separate. So we're going to do y equals 7. And this is when x is less than 4. Right? A little table. It is a line. It is a special line because it doesn't have an x. Right? Y is always 7. And for your x, we want to use a 4, but that will be an open circle because there's no equals. And then we have to have things less than 4. So let's say we pick a 2. 2 is less than 4. So we'll graph that one. So we want an open circle because it's just less than. And our point's 4, 7. 4, 7. That's our first point with an open circle. Then we're going to click the ray tool because it is a line. Go back and click that point. Our next one is 2, 7. So over 2 up 7. So it goes this direction. Now we'll do the other one. So y equals -3x plus 14. And this one, x is greater than or equal to 4. So we'll use the 4. And it will have a closed circle. So this is y equals -3 times 4 plus 14. This is -12 plus 14 will give us 2. Right? And we want something else that's bigger than 4, so let's try a 5. So we have -3 times 5 plus 14. So this is a -15 plus 14 gives us -1. Right, so this one is going to be a closed circle at 4, 2, and then we're going to plot 5, sorry, we got the point, we hit the ray tool, go back to the point, click it again, and now you're going to do 5, -1. Right, so there is our whole graph for this piecewise function. They ask us the range, and this time on your range, you have a gap in there. Sorry, let's see if I can get that back down there. All right, you have a gap, so you have to leave this piece out. So we're going to have to do a union. So we want to go lowest to highest. So this is coming from negative infinity up to 2. And this was our second one. And so it's going to equal that point. So that point will be a bracket. So we are coming with parentheses. I'm just going to use the keyboard here. Parentheses, negative infinity. Sorry. Negative infinity, comma, and we said that goes to a 2, and we are including that, so that will be a bracket, right? Then we're going to have a gap, so we'll do a union that is under the interval button, right? And then we just have this number, and so this is 7, and then the way we have to put that in is with 2 brackets like this, and just use the value 2 times. So we'll do bracket to bracket 7. And then they want to know f of 5. So when x is 5, it will be negative 1. Good. We're going to look at another piecewise function, and this one of them is aligned. The other piece is actually not aligned, and we're going to do this one on a calculator. They just give us pictures to choose from. So I'm going to show you this on the calculator. So we'll do y equals, and so we'll enter this first part, and then we have to do something special to get our condition on. So we're going to enter our parentheses, x plus 1 close parentheses to the second power. And remember, you have to do something if you have that TI-84 to get your cursor down, minus 1. Right, now you're going to do a divide, and that is really just separating here, and you're going to put your condition in a parentheses. So we want x to be less than negative 1. So you put your variable, and these symbols are under the test menu. So you're going to do second, because it's up above the math menu, math, and there's your logic symbols. So we want less than, which is going to be number 5, negative 1, and then close that parentheses. Right, you can click enter, or you can do your down arrow. Right, this one will be a line. Y equals 2x plus 7. Right, whoops, that wasn't plus 7. Right, we have a condition again, so we'll do that divide to separate parentheses x, and then we want to get to our test menu again. So second and math to get test, greater than or equal to is number 4, -1, close parentheses, and now I'm going to graph. All right, so it doesn't give you your ends, but since it's a multiple choice question, we'll see how we can do from here. It's not this first one. Sorry, I don't quite have the hang of this tool yet. All right, so it is not the first one. It might be that one. So it's number 2. We'll have to check those endpoints. You know what? Get on there. All right, so here we are. This is not the first one. That one's out. Right. Possibly it's the second one. Possibly it's the third one. Those are similar. And I need to keep going down. I think there's more. Okay, the last one is out. So it's between these middle two, and we have to see on the parabola, that would be the equals underneath. So let's see if we had that in our equation. No. So we want the solid circle to be on the line, because this one is the line. And so it would be this third choice. All right, and now we're going to have to do the range. So lowest point, it looks like the lowest point is a -1. So a -1, and we're not touching it. And it goes to infinity. So the range, -1, and I said we're not touching it. So we're going to have parentheses. So -1, comma, infinity. That should be the range. So it's the whole graph. And we picked this graph. So here's your lowest, goes forever. And those cross, there's not a gap in those. Right now it wants to find f of 3. So we'll go back to the right picture. I'll also show you on your calculator how to do that. All right, so 3 is going to be on this picture, and it's off of there. So we could do it algebraically looking at the equations, or it's a good time to do another thing on the calculator. So if we, and what was it we said, 3, f of 3? So f of 3. So you could do it algebraically. You would have to pick this one. So it would be 2 times 3 plus 7. I don't want to write on there because it might click off my calculator. Right. So we're going to do that on the calculator. So this is a one that you use a lot. So second calc, and we want to do choice number 1, value. Enter. And we're going to let x be 3. Enter. And I guess I haven't ever tried that before with my conditions. So let's see, x be 3, we'll do this one algebraically. Okay, so 2 times 3 plus 7, so 6 plus 7 will be 13. I think it was because of the conditions on there. All right, so it looks like if I move this with the pen, it works better. Very good. All right, we have one last type of question in this section, and it is called a difference quotient. The difference quotient you can see here, f of a plus h minus f of a over h. And they want us to calculate that for our function. So our f of x, 6x minus 5, and they first want us to find f of a. So you're just going to replace your x with a. So this will be 6a minus 5. That will be for our first box. Right? The second one, they want us to put a plus h into x. So however many x's you had in your problem, that's where you would put it. So we'll have to simplify here, which gives us 6a plus 6h minus 5. That is the f of a plus h. And then we want to do the difference quotient. So we're going to do the f of a plus h, which is this one. We're going to subtract f of a, and this is where you have to be careful. You want that subtract to go to the whole thing. So you want to do minus 6a plus 5. Right? And all of this will be over h. And then we will simplify. So let's get a different color. Our 6a and minus 6a are going to cancel. Our minus 5 and plus 5 are going to cancel. So we are left with 6h over h. And the h cancels, so this simplifies to 6. So you mainly just have to watch when you're plugging these in. This is a real key step when you have to distribute that minus.